Hey Precalculus. So yesterday we looked at a revenue problem, and here are the notes for something like that. So in this situation we have a hockey team playing in an arena. The seat capacity is 15,000 spectators, and when the ticket price is set at $14, the average attendance at recent games has been about 9,500 people. So there's been a market survey, and in that market survey it's indicated that for every dollar the ticket price is lowered, the average attendance increases by 1,000 spectators. And what we're going to try and figure out is what ticket price is going to maximize the revenue in this situation. To begin with, let's just think about what happens in the beginning of the problem. So we've got our ticket price set at $14. We've got the attendance at 9,500. And we've got our revenue. Now, to figure out the revenue, what I'm going to do is multiply the ticket price times the number of people that show up. So 14 times 9,500 gives me a revenue of $133,000. Not bad, not shabby for a hockey arena. Okay. And now if I lower the ticket price by $1, my average attendance is going to go up by 1,000, so now it's going to be 10,500. And my new revenue is going to be 13 times 10,500. So now I'm making a little bit more money because I've lowered the price, but more people are coming, and so it's making up for that. So let's see, that's 136,500. And I could lower it another dollar. That's going to mean that 11,500 people are going to show up, or hopefully going to show up. And that means I'm going to make 138,000. Now you could probably solve this problem by continuing on in your table. These are essentially guesses and checks, right? You're wrapping your head around how the problem is working, you're trying to notice some patterns. Because this is pre-calculus though, we're going to actually turn these into models. So one for ticket price. I'm going to let T be my ticket price, and I notice the ticket price starts at $14 and then it's lowering $1 every time I make a change in the price. So I'm going to let X be the number of times I'm changing the price, or how many dollars I'm lowering the price by. Attendance I'm going to call A, and I notice that I start at 9,500 and it's going up by 1,000 every time I change the ticket price. So I'm going to add 1,000X. And then my revenue, I notice, is my ticket price times my attendance, and that's giving me my total revenue. Now that I have some models set up, I can use substitution. So I'm going to plug 14 minus X and 9,500 plus 1,000X into my revenue formula. So for ticket price, I have 14 minus X, and for attendance, I have 9,500 plus 1,000X. And now, since this is a problem that's looking for a maximum, I know I'm going to have to graph this and find the maximum of this revenue graph. So I go into my graphing calculator, go into my y equals, and I'm going to plug in 14 minus x times 9,500 plus 1,000x. And now, again, just like normal, I need to make my window something where I can actually see what's going on in this situation. Recall that the X that I'm using here is the dollar amount I'm lowering my ticket price by. In this situation, since I'm starting out at 14, most that X would be 14, because if I take away for, like, basically I'm giving money back for the tickets, right? So in terms of my window, I know that can't go past 14. That doesn't make any sense. And then in terms of the Y value, 136, 138,000 in terms of making more than this. And so my graphing calculator to see about how big my numbers are going to get. Oh, and you notice that after $3 you start losing money. So you've lowered the ticket price so much that you're losing a little bit of money there. So it looks like 138 might be the highest price. I'm going to go just a little bit higher than that to make sure. So in my window, I'm going to make sure my Y max goes up to, I don't know, 150,000. And then I better make my scale adjusted. I'm going to just drop a 0 off so I get 10 tick marks. Now when I graph it, I should see a portion of a parabola. So it's a parabola because I have an x times another x, so I know I'm going to get an x squared there. And now I want to find the maximum, so I'm going to go second, calc, max, left bound. I'm going to choose, well, I can just scroll. I want to be on the left-hand side of the maximum. So here a little bit. Hit enter, and then enter again. And I get a maximum of 2.2, probably rounds to 5, 2.25, and $138,060.50. So to show my work, so that somebody looking at this understands how I got the answer, I'm going to draw a picture of the graph. I'm going to label my axes a little bit at least, so 0, 14, this was 150,000, this was your change in ticket price, this was my revenue, and then I found the maximum, and the maximum was at 2.25 and $138,062.50. Okay. And then the question says, what price maximizes the revenue? So for my final answer, it's always nice on problems like this to actually write your answer out in words. So the ticket price, this is how much I'm lowering it by. So actually on my calculator, I need to go ahead and do 14 minus 2.25. So $11.75. The ticket price should drop by $2.25 to $11.75 in order to make a maximum revenue of $138,062.50. This is what I want your answers to look like. On problems like this, please take a second and write out a sentence that explains what your answer is and make sure that it actually answers the question. Alright guys, that's it for notes for tonight. Make sure you get everything copied down, and you might want to add in a couple of side notes about the steps on the calculator if that's something that you are unfamiliar with. And I will see you in class tomorrow. Thanks.